Hello, everyone. Good morning, good afternoon, good evening, depending on your location. Today, I'll be talking about a rather provocative statement, which is why public cloud is on the way out, and I'll be happy sharing my views on this. In terms of who I am, so I'm a Daniel Virassamy. I'm a principal solutions architect. I am based in Paris. I've been working for Mirantis for quite some time now, and I've always been an open source aficionados. I've started my career building, coding in Linux. I continued in OpenStack, and now I'm doing more and more Kubernetes. So I'm a big advocate of the open source components, products, projects. So let's directly dive into the actual statement. And this one made me laugh a little bit. I didn't even search for it. It came on my LinkedIn thread, so I wanted to share it with you. And that can be the case. We sometimes forget our EC2 instances, and then you get a kind of notification and says, well, you've been spending quite a lot of money. Is it important to keep them up and running or not, right? Yeah, this one was funny for me. But if we look at the promises of public clouds and the reality, I think it's quite nuanced, and we have a paradox. And the whole session will be talking about that paradox actually. So let's look at who gets the real benefits of public clouds, and how this paradox come alive. You have two traditional consumption model. You have the capex model and you have the opex model. And when you look at the capex model, you start by doing your capacity planning, you provision your infrastructure and services, and that infrastructure will be able to sustain a certain level of capacity, irrelevant of the usage or not, right? And as you grow your usage, you will bump the capacity and thus increase your capex. So typically, when you start your project, this is how the high capex cost comes in, versus when you then need to grow your usage, and this is where the capex model is more interesting. On the other hand, OPEX is completely different. OPEX will follow your consumption based on your usage. So when you begin, you have a small usage, and this means that you will only pay for what you are using. And as you grow, you will continue to pay for what you are using. But you can see that if you look at that red line and that dotted line here, at some point, you have that tipping point where the capex model becomes more interesting than the opex model, right? I like that statement. By preparing this webinar, I also read quite a few articles, and so I will be quoting some of these very interesting statements that I saw. But and I like this one also. You are crazy if you don't start in the cloud. That's true, because of that OPEX flexibility at the beginning. But you're also crazy if you stay on it, because of that tipping capex line at some point, right? And that's all which is very interesting about the cloud paradox. So when you look at the use cases and how it is then attached to this paradox, when you are a startup or when you want to experiment fast, it makes sense to start on public cloud, because you don't need to have that high cost at the beginning to set up your infrastructure. You don't need to hire dedicated people to set up this infrastructure. You don't need to manage this infrastructure. You don't need to think about scaling this infrastructure. You only think about developing your application and the go-to-market. And the same for fast experimentation. Whenever you need to experiment something around your implementation, it is interesting to use public clouds, because it allows you to rapidly learn the implementation and take benefit of the platform without having to again take upfront every tasks to make to deploy your application. And obviously the cloud search and search in many ways, in terms of you need to onboard a lot of people rapidly, right? So instead of looking for stuff and handle the search, you can rely on the cloud platform. If you have, depending on the profile of your traffic, if you're expecting a lot of load at some point, you can offload some of that load towards public cloud. So these are the very interesting use cases where public cloud come in very handy. But as you grow your business and as you have that ability to do better forecasting, better customer acquisition, better cost management, you will have again that tipping point between OPEX and CAPEX. And this is where cloud platforms and cloud use cases are becoming more and more in that red spot of can I manage my cost? Can I take full control of how the business is going to grow? Can I manage the margin? And can I also take care of the development of my platform without being completely locked into a given single platform or a given solution, right? So that's very important to understand. So an important and interesting question about public cloud is why data is so cheap. So they do have a lot of data services, whether it is database services, whether it is data storage services, block, object, file storage. They have data warehouses. So they are very complete in terms of data offering. And handling data on public cloud is cheap. Is definitely cheap. If you look at S3 pricing, for example, and all the tiers of S3 pricing on AWS, you definitely do not pay a lot when you get data in. But then it is a very well-oiled machinery. And again, I'm quoting one of the articles I read, which was very interesting, about from becoming friendly to scary very rapidly, because at the beginning you have a lot of good offerings, good pricing for data, a lot of free tier, and a lot of vouchers, right? So use the credits, onboard your applications, and start to develop on the platform. But I believe that nothing is ever free, right? And I don't believe that even the free tier is really free. Then you have help. You are helped by the cloud architects. They provide a lot of onboarding courses, onboarding sessions, and you have that I am a hero syndrome. I can deploy rapidly applications based on what the cloud architects are giving me, and I can rapidly onboard and deploy any of these features and services across their different platforms. And as data is cheap, the customers continues to scale up. They deploy in one region, one or a couple of AZs, and they just scale up the application and just onboard more and more data. And this is where the scary part comes in, because you have that bill shock. The cloud bill explodes, and many of the customers will try to optimize. That comes with very specific skills, and these are not very easy to find. People that are trained to do FinOps and to continuously get their skills up to date, to make sure that they can read through all that complex cloud billing system. And it's often a big struggle. And that struggle also comes then with limiting the features that you're using, and then you come into a situation where you're not even getting the benefits of all the features that these cloud providers are offering, simply because of the complexity of the pricing. But the problem is too bad, right? Many of these customers can't get out of that situation, because you're completely locked into this because of various reasons. Egress cost is one reason. Very cheap to put data in, very expensive to put data out. And I'll be showing some numbers afterwards, but that's also what I call the iceberg model. And this is something that they also typically use. Public clouds like to use the iceberg model and say, okay, for the on-prem or private cloud, you will have a lot of hidden costs with people, with infrastructure to manage, etc., etc. So you can also do the same if you take that same parallel with public cloud pricing model. It's quite easy to read the pricing mechanics behind spinning up virtual machines, spinning up container services, using object storage, using block storage, using databases. For this, it's quite easy, right? The parameters are quite simple. The problem is when you add all these parametric services, like I need load balancers, I have various types of load balancers and different pricing sometimes, public IP addresses, if you're using elastic IPs, security rules, the metrics and logs with for example, in AWS CloudWatch, you have various ways of handling various parameters for the pricing. If you're replicating data across regions, the cost of copying data from one region to the other, the cost of egress traffic, and various specific metrics depending on the service that you're using. IoT, for example, is something which is also very interesting. Very low cost on storage, very high cost on computing, right? So that's the what they call the cost ratio. So this is all which things that you will discover, and that this is where the bill shock comes in typically, because yes, you have your services running, but then you have all these associated services adding cost each and every time, and at the end, it's just a big shock. These are some of the interesting data that I also saw recently on the cost of moving away 50 TB of data out of the public cloud. I believe this is interesting because when you look at these names, right, it's quite interesting to understand why the big three players, Azure, Google, and AWS, are so expensive compared to the other players, and including Oracle, for example, right? And the difference is quite important, because if you look at IBM Cloud or Oracle Cloud or even OVH, you have a massive ratio between these players, 10 times or more than 10 times. And this is a clear indication of lock-in, definitely. And as Antoine Joel says, egress cost is a nightmare to understand, and forecast is very hard, right? And you are not in the driving seat. Today, that's the cost, and tomorrow, maybe the cost will be double or triple. So you don't really are in the driving seat. You are putting your data in the public cloud, and if at some point, for various reasons, whether it is sovereignty, whether it is regulatory, you need to move the data out, you can't forecast the cost of moving the data out, right? And this is something that typically is very important to consider, because you can be in a very tricky situation. That statement was also very interesting. You need less staff, right? Typically, because you don't have your data center anymore, and everything is on public cloud, you need less staff. Is this really the case? And someone also shared that on LinkedIn, and I liked it a lot. And when I see all these different blocks, I don't believe that you really need less staff. These are very specific services where you need specific skills, right? And yes, you can train on all these services, but if you need to understand how a graph database works and be an expert in graph database, why would you also be an expert in how load balancing works, right? You have very specific skills, and each of these means you have staff to maintain that. If you're in a multi-cloud, this is one design you will be doing on one cloud, and then basically you will be doing the exact same thing on the other cloud, right? So this means double the job, because the API codes are not the same, the services are not the same, the different ways of putting the parameters are not the same. So basically, again, you need to at least understand all this to start deploying your code and start deploying your services. So yeah, do the organizations really have less staff? No, I don't think that they have less staff. The staff is doing something different, definitely. But again, how valuable it is for the organization at the end of the day can be questionable in many cases. And then it's a race for certifications because of all these services, whether it is on AWS, Azure, Google, 11 certifications on AWS, for example, right? And you do want to have all of these certifications as things that you are collecting. But I like also what NDJC, previous AWS CEO, said. There is no compression algorithm for experience. So it comes with time that, to perfectly handle security, to perfectly handle networking, to perfectly handle big data, machine learning, and AI fundamentals. You need to have that experience, right? So yes, it then becomes a race for certification because you need to manage this sort of environment, but you are spending a lot of time and energy managing that. And at the end of the day, yes, you have shifted from managing physical servers, managing virtual machines on-prem, to managing AWS and cloud services, and you still have people that needs to develop on top of that. Right? So what about margins? And this is something which is key also, and related to the cost and related to the egress cost. So let's look at some of the examples that where organizations had to optimize their infrastructure because they were seeing that the cost was getting out of control. Right? Apple is a good example. Apple in 2018 was paying around $775 million to AWS per year, right, which is massive. And they decided to retake some control and build their own data centers. Just to get the data out, that was around 50 million at that time. So that's okay for organizations like Apple at that scale. Well, I'm saying it's okay. They have the capability to do it because they have the ability then to recover that amount, that value. Sorry. Can this be the case for many other companies? Can be also questionable because this is quite a large value only to get back your data, right? So easy to put data, very hard to get out, and this is something which is very, very central to consider. Pinterest was in the same case. Pinterest paid 26.4 million to get back data in 2018, and 14.7 in 2017, right? So again, at some point, these companies need to take that decision and start to repatriate data because they forecast that the cost again will just explode, and at some point they need to make that call. But it is a painful decision. And Dropbox, this is a different example, but Dropbox was able, and I'll show that in the next slide, but was able to reduce the overall spend over 2 years prior to IPO, around 2017. So 75 million cumulative savings, and this is also very interesting, and this has an impact on the margin basically, right? But by doing optimization and continuous optimization and properly thinking about repatriation and what needs to be brought back, you start small, you explore and experiment rapidly on public cloud, but you have that tipping point where CapEx is more interesting than OpEx. And this is where Apple saw that tipping point. This is where Pinterest saw that tipping point. And these are some of the examples, right? You have a lot of other examples. And this is where Dropbox also saw that example. Another very interesting metric is the committed cloud spend as a percentage of the cost of revenue, right? So the cost of revenue is how much it costs you to build revenue or sell your services, and committed cloud spend is what you're actually spending. And when you look at some of these organizations, like Slack, for example, in that document, you can see that Slack is paying 41% of, well, he's spending 41% of the whole cost of revenue and this is quite large, right? And then you have all the rest, which is marketing, which is sales ops, and all that stuff. So so again, the infrastructure and cloud spend can be quite high, and this needs to be at some point put under proper control. The impact on margin for Dropbox, to be able to reduce down to and do that 75 million cumulative savings. So it went for a lot of effort, right? But you can see that as they optimized, they were able to reduce definitely that cost of revenue, right? As they were optimizing, they continue their growth. They continue their growth. You can see that the growth is definitely increasing. But very interestingly, the gross profit and gross margin increased, right? And the reason they had to increase the gross margin is because of IPO, and the document explains quite interestingly how margin is related to market capitalization, right? So as you increase your margin, your market capitalization goes higher, and this may be something which is hidden, but at the end of the day, you have that close relation between margin and market capitalization. I also wanted to reflect on parallel, as many of these companies are optimizing so as to be able to get these savings in terms of managing infrastructure and managing the infrastructure, whether it is cloud infrastructure or private infrastructure, to improve that margin. In parallel, you can see that the margin of AWS is also increasing quite steadily, right? So you do have some flat parts, but basically you have that margin, and one of the latest values that they shared was around 30%, right? So they are also increasing their margin over time, right? So that's also a good indicator of how pricing is growing and managed by these cloud providers. The public clouds like to talk about architectural pillars, and AWS, for example, they have these 6 pillars around operational excellence, security, reliability, performance efficiency, cost optimization, and more recently sustainability, right? And these are all valid pillars. You do need to improve the way that you are operating your cloud clusters, environments, and apply all the best practices around that. And this is true both for public clouds and for private clouds. Security, right? Job zero, no question. You don't want to be in the headlines. Reliability, obviously. You need to provide a reliable platform so that your tenants, users, are happy to host their services on top of that, and your customers can access the services at the proper time, right? You do have a system that fails. AWS region failed at some point. Recently, one of the Google regions in France, completely failed. So reliability is a shared responsibility also between the platform provider and the application owners. Performance and efficiency continue to grow as you can, and you have various ways of doing that, and do that with a proper cost management. And cost optimization is very interesting here, because you do have that as a pillar, but still you have that shock bill effect. So this is not something which is perfectly transparent and easy to understand, right? A lot of hidden costs that you basically at the end of the day discover. And sustainability, of course, very important. We need to see how we can improve the way that we are providing these platforms by recycling servers, for example, by reducing the power consumption, by using lower consumption CPUs and all that, right? So there are a lot of things that are very important at this pillar. But where is reversibility, right? And definitely they will definitely not provide such a pillar. but reversibility is very, very key. Many companies actually have that as a mandatory item in terms of strategy. You need to have a way of taking back your applications and putting them into your environment, whether it is private or something which is hosted, co-located, or on another public cloud platform. But you need to have that capability to get back control on your data. If we go back to the egress cost, for the cost of 50 TB, for example, very, very high cost on these public clouds. If you look at some of the examples at Apple and all, I don't think that the reversibility is real for everyone, because basically, if you have data which is valuable for you and you need to get back that data, the cost is prohibitively high to get back, right? So reversibility is definitely something which is not real because of the data lock-in. So something, again, to be very, very careful of. So what are the solutions? And here I'm not going to it's not going to be a revolution, right? I'm a big fan of the principle of keep it simple. We already have a lot of skills on the market. We know how to build data centers. We know how to manage data centers. We know how to deploy services in these data centers. You have a lot of champions in various domains, and these champions have basically provided all the required services, and some of these are actually being used by the public cloud, right? Like, for example, Elasticsearch as a company and an open source product is something that is used and even forked by AWS because of licensing issues, right? OpenSearch, for example, not happy with how OpenSearch changed licenses, fork the project and take it as theirs. So let's keep it simple, no revolution, and use what we already know. Open source is key. Definitely, I'm a big open source advocate, but open source is very, very key. And many of the services that actually are being deployed and used on public cloud are based on open source projects. In RDS, for example, many of the databases, AWS RDS, many of the databases are open source based. Postgre, MySQL, MariaDB. The message queues are open source, RabbitMQ. The container services are open source, Kubernetes, right? So you have a lot of these open source projects which are already embedded, and where they are margin, right? Where the 30% margin comes in from AWS. So use these and keep your developers happy, because your developers are happy using these open source projects. And open source for me means sovereignty, right? You have access to the source code, you have access to the IP at the end of the day, and you can take it as yours and make it yours and continue the development, contribute to these projects, and use it as you want. Definitely, you have some required skills, but you are not locked at any point. If you're using a component which is in a given environment, you're not happy with that with your partner, you can move to another platform and use that same solution, but with a different partner, right? So open source is something which is very key. And again, keep your developers happy. Data governance. I talked a lot about cost. I gave some examples about cost, and many of the lock-in situation and cost issues comes with data. So you need to have a proper data governance strategy. Who owns the data? Who needs to have access to the data? How to secure the data? How to do quality around the data? And all the knowledge that you can achieve with that data, right? And based on that, you can then decide through people, through technology and process, where you need to host that data. And you have various services that can be used then to host the data. It really depends on your use case. Caching data, for example, or if data is just used temporarily, okay, there's no problem to put that in public cloud, because it will disappear naturally, right? It will just be there, disappear naturally, and you don't have any egress cost. But if you have data that you need to keep for multiple years, and you have a big probability of needing them or not needing to get that back for various reasons, then public cloud is definitely not the right solution because of that egress cost. If you do the TCO, most probably an on-prem solution or a private solution. I'm not going to say on-prem because I'll differentiate on-prem and private later, but a private solution would be a better fit. And you do have a lot of options today. The CERN, for example, uses a massive safe cluster, open source based solution to save their data, right? So this is a very critical platform, and they are able to store that amount of data on an open source based solution to reduce the overall cost, right? Imagine putting all that data in public cloud and having to retrieve that at some point. So yes, data governance is very, very important. Do not hesitate to publish your policies and review that through your processes, so that you continuously improve and you make the right decision of where you are going to position your data. And then cloud to hybrid to multi. I think it's time also to end the argument of I'm going to do everything in public cloud, right? Or I'm going to do everything in prem. It's not that simple. You have services that are very, and many services that are very, very well done in public clouds, and other services that needs to be on-prem. So it's not a war of public cloud versus on-prem. It is more public clouds and on-prem platforms. And it doesn't need to be one or the other. It needs to be both at the end of the day, right? Because you have benefits using both, and you have massive drawbacks using only one. When we discuss the 7 pillars, 6 pillars / 7 pillars with reversibility, which is a missing pillar. Yes, you have the same thing that applies here in a multi-cloud environment. You need to have operational excellence, right? So central management, simplified deployment, observability. You need to have security. You need to have performance with proper monitoring. You need to have reliability. You need to be sustainable, and you need to be reversible, right? So this is something which is key and applies across these different environments. Private does not mean on-prem, and again, this is something that it's not many people confuse, but typically we try to do that. We take that shortcut, right? Or private is on-prem. No, private doesn't really mean it is on-prem. You can there is a challenge, of course, if you have applied a exit data center strategy and move to the cloud, and then you need to get back because of again that loss of cost control, and you need to be more in control. And Apple, like Apple created or started to build their own data centers again. Yes, but you don't need to have that on-prem. You can work with various partners to set up the proper solution, right? So you have co-location services, and you actually will be in the same co-location sites as the public clouds. Like if you are in Equinix, for example, many of the AWS data centers are in Equinix premises. You will have the choice of your hardware, and hardware is fun again. So you can select AMD, Intel. You can select AMD, a lot of with high CPU density. But if you want to go low CPU, low energy usage, you will be going with ARM, right? And again, you have all these partners: HP with GreenLake, Dell, Lenovo. They are all providing hardware under the OPEX model also. So you can already start small under the OPEX model and grow with them and move towards the CAPEX model, and it's going to be way easier because you don't need to have that data out again, or data exit, or data egress cost, which is attached and which just locks you into that situation, right? Equinix Metal is another partner, interesting partner, where again you can use under the OPEX model. You can get hardware, pay as you go, and scale out appropriately. And obviously, Kubernetes is the killer app. And that's actually what also was confirmed by the Indian customer that did a testimonial with us a couple of months ago. Kubernetes is a game changer, right? So obviously, if you would apply the proper strategy and say, okay, think about repatriation upfront. So I'm starting small. I want to do it on public cloud. I want to, as a startup, develop my applications, do experimentation, and grow my business on public cloud, right? But you also need then to think about how you are going to repatriate at some point, because again of that tipping point. So think about repatriation upfront. This is something which is important. So put cloud spend as a KPI and closely monitor that, so that you know when cost is starting to be out of control. You can also incentivize the right behaviors by, for example, putting some money on the table for the engineers that are reducing the spend and optimizing the whole setup, right? Shutting down workloads during weekends, use spot instances, do any optimization they can, right, to reduce the cost. And then optimize. Continuously do that. Think about how you can optimize. Think about which services are needed, which services are not needed. Use open source solutions, and think about how you're going to get out, right? The companies need to optimize early, often and sometimes also allowed outside the cloud. When you're building a company at scale, there's little room for religious dogma. And this is very, very true. It's not about being pro public cloud or pro private cloud. Again, it's a mix of both worlds that needs to be used. Through that, we have the notion of landing zone. So this is one landing zone for a pure Kubernetes cluster. And we can design to run in less than 1 hour, right? And when I say 1 hour, it is a full-fledged Kubernetes environment with the Kubernetes distribution, with a proper configuration in terms of RBAC, with a proper configuration in terms of CNI, CSI, and CRI, with a registry, which is called Mirantis Secure Registry, with the logging, monitoring, and alerting stack, Lens Autopilot, which is additional services that comes to complement the Kubernetes distribution, and adding security components, service mesh components, CI/CD components, logging, monitoring, and alerting components on top of this Kubernetes cluster. And we do the management also through a multi-cluster management system, right? If I just rapidly go to this web page, let me check if I'm still logged in. I'm still logged in. This is the Mirantis multi-cluster management system. The deployment of this cluster would be as easy as the following. I would select a namespace. And within that namespace, I would just create a cluster, give it a name. Select the environment on which I'm running. So in this case, I'm running it on a private cloud, which is OpenStack based. And just click on create. I can put some servers here and external network, all right? Just as an example, right? And once this is done, I can just create the machines. Okay, just create the machines here, and the same here. So through very simple operations and clicks, within a couple of minutes, I can define and deploy these Kubernetes clusters, right? So it is a self-service off-the-shelf offering where within a couple of minutes / hours, right? I extended it to 1 hour here. You can design and run your Kubernetes cluster, the same experience you would have on a public cloud, right? But in many cases, you still need to have an environment where you would be running your Kubernetes cluster. And this is where we, Mirantis, we come in with an OpenStack cluster, right? So OpenStack is like Linux. Okay, some people will say OpenStack is hard to manage. Yes, but OpenStack is a very young project at the end of the day, right? It took a lot of time and years for Linux to reach that point today where a lot of people can consume Linux. But in the beginning, you had to compile your kernel, you had to go through a lot of configuration files, you had to set up a lot of libraries in your system to be able to do that. OpenStack has also came a long way, and we Mirantis, with Mirantis OpenStack for Kubernetes, we have massively simplified the user experience and made the user experience very, very easy around OpenStack. And as you have that private cloud, whether it is on-prem or in any of your environment, you have your own private cloud where you have a real cloud with OpenStack, with network compute capabilities, storage capabilities, and network capabilities. And when I say storage capabilities, I mean block, object, and file system storage capabilities. And when I mean network, I mean full control on overlay, full control on underlay, and full control on microsegmentation, right? For complete isolated environments and microsegmentation. You have that real that self-service experience, cloud experience that is provided by OpenStack. And then on top of OpenStack, you can run your Kubernetes clusters and registries as I showed earlier, right? And again, designed to run in less than 2 weeks. So you would design your cluster, and in less than 2 weeks, you would have your cloud environment ready to use. And on top of that cloud, you can then provide that to your users, tenants, so that they can self-service in a self-service manner, consume resources in terms of virtual machines, in terms of networks, in terms of storage, in terms of load balancing, in terms of DNS services, in terms of vault and security services. They can use all these different services and host their applications, whether directly in virtual machines, because I don't think that virtual machines are going anywhere. They are still here for a long, long time. And definitely you can run your applications in Kubernetes, as many applications are also being ported into Kubernetes. The subscription model is very, very, very simple. Here we have either a per node or a per core subscription model. So in the way that you are going to calculate, forecast your cost on private clouds is going to be very simple, because it's predictive. It's predictable. Sorry, and it's you can forecast that compared to the more complex public cloud model, where you have a lot of these parameters to take into consideration. Here, the model is very simple. Either it is a per core or a per node subscription model, 1 year or multi-year. And we typically take the most advantageous for you. So we would look at your use cases, and if the per core makes more sense, we will be applying the per core. But if you prefer to use fat servers with a lot of cores, then the per node will be more interesting for you. Then we will apply the per node for you, right? Very transparently. And this comes with the zero-ops approach, and the zero-ops approach is supported by the support model, OpsCare and OpsCare Plus. OpsCare is a co-pilot model where we assist your team to support and manage and maintain the private cloud platform. But if you don't want to do that again, and you just want to handle and provide these resources to your users and tenants, you have the fully managed service, which is OpsCare Plus, where we would be doing everything. And this is where you would have the private cloud user experience very, very similar to public cloud. This is typically what we call the AWS on-prem experience, right? So it's as having AWS on premises, but with open source components, open source solutions, open source clouds that can deliver virtual machines, that can deliver storage, that can deliver networking, but that can also deliver Kubernetes as a service offerings. All right. So I'm at the end of the webinar. I hope it has been useful for you. It has been interesting. It is a series, so we'll have our next webinar on the 80th of June, which is a continuation of this one, right? On-prem data center plus public cloud, which is a perfect match. So we are in the same thing of hybrid or multi-cloud environments. So yes, it's on Brighto. Do not hesitate to register, and we'll continue that discussion. Again, thank you for your attendance. Hope it was useful, and hope to see you in our next webinar. Have a good rest of your day, afternoon, or evening.